In this video, I will teach you how to use Visual Studio to debug your Unity projects. Debugging is something that we do as programmers whenever we have some errors in our projects and we will need to locate and fix those errors. So to be able to follow along with this tutorial, I will need you to download Visual Studio and install that, and also install Visual Studio debugging tools. If you have Mono Developer, you can also follow along with this tutorial, but you will have to figure out yourself how to set up a Mono Developer for debugging. Because I'm always using Visual Studio, and this is the IDE that I have chosen to show you how to debug your projects in. If you haven't installed Visual Studio already, you can click the link in the description below to get it, or you can click the link on the screen right now to navigate to the Visual Studio homepage. Visual Studio is an IDE by Microsoft, and as for now they have 3 different versions of this IDE. They have Visual Studio Community, Visual Studio Enterprise, and Visual Studio Code. And the version that we are interested in is the community version, because it's a free version and it has all the features that we need to create games and debug in Unity. So if you don't have it already, then go to this page and download the community version and install it. When you have installed the community version, you will have to install Visual Studio tools for Unity. And the Visual Studio tools actually comes with Unity right now. So whenever you install Unity, I'm just going to open up a new installer here. Then you'll see that you have some different options when installing Unity. So you simply have to re-download Unity and open the installer, and then make sure that you check Microsoft Visual Studio tools for Unity here. So when you've done that, Unity will install, or the installer will install the Microsoft Visual Studio tools so that you can start debugging your programs. Okay, so when we have installed Visual Studio, we have installed the Visual Studio tools, we will have to go to Unity and make sure that Unity uses Visual Studio as the IDE for your projects. So what I would like you to do now is to download the project. If you want to follow along with the tutorial at least, I would like you to download the project from the link in the description now, or click the link on the screen right here. It will take you to a page where you can download this project that I have here, and it's set up for some different errors so that we can start debugging and finding those errors and correcting them. So the point of this project is actually to teach you to debug a project and find some different errors by debugging. But when you have downloaded the project and opened it up, you can go to Edit and Preferences. And in here you'll have to make sure that this project uses Visual Studio as your IDE. So click on External Tools, click on the External Script Editor, and you'll see that I have selected Visual Studio 2015 here. Yours might be using Mono Developer like this, the built-in version, but if it does that, you have to click here and select Visual Studio 2015 and then close it down. To make sure that everything works, we can go to our scripts, we can right click, click Create, and C# script, and just create a new script called debug test. So debug test is our first script that we're going to use, and when you open up the debug test, if I do it again here, it should open up in Visual Studio here instead of Mono Developer. When you have opened up the script, the newly created debug test script, you will have to go to Scenes and select the debug log scene here, which is just an empty scene. So when you have created the script and open up this scene, you are ready to continue with the tutorial. Okay, so before we start looking at the actual project that I created and we try to debug it, we will have to take a look at what debugging is and how it works in Visual Studio. So basically, debugging is a way of pausing the code so that you can inspect the different items or the different variables in the code while the code is still running or while the game is still running. And we do that by putting something called breakpoints. And the breakpoint is placed by clicking the margin all the way to the left here. There's a little darker area here. You can see if you click over here, you're placing a breakpoint. And when the code actually reaches this breakpoint, it will stop running the game and break and show the code so that you can inspect the different things in here. So right now, if I just play the game now, and I take my debug script here and put it on my main camera, remember to put the script on something, and we're just going to use it for the main camera. So take the debug script, drag it onto the main camera so that we can run it. If I run it right now, nothing is going to happen because I haven't told VisualStudio that we are in debug mode or that we are debugging right now. So if I stop playing the game, jump back into VisualStudio, you will see that in the top here there is a play button, and to this play button actually says attach to Unity. So if I click this button here, it will attach itself to Unity, which means that when the start function is run in my game, it will break here so that the code will stop running. So let's try one more time. After you have pressed the play button, go to Unity, play the game, and then you should see that the code actually breaks in here. You can see that now Unity isn't running, it's running in the background, and the code has stopped here where I have my breakpoint. But this is not very interesting right now because we don't have anything to inspect and we don't have anything to jump into and stuff. So let's try to press continue here to let the code continue, and then it runs again the code. So if we stop the game and go back into VisualStudio, we can try to make a string up here. So let's try to press the stop button so that we can edit our code. And in the fields here we write private string called message, and we make this message into a serialized field. Okay, so this is our message, and we would like to write it in our debug console. So we simply write debug.log message. So now we are writing this to our console. So let's try to save this, keep the breakpoint, attach to Unity, and jump into Unity. And on the main camera we have the message here, and in the message field we can write hello world. So here we have hello world now. Let's try to run the game and see how it affects our script. So if you run it, see that it breaks. And the thing is, when you're debugging, you can inspect the different variables to see what the values they have. Because maybe you have a game where you're attacking a player and you don't understand why the player doesn't lose health. And then you can inspect the different damage values to see how much damage the player needs to take, for example. And then you can see maybe the damage is 0, so that's why the player doesn't take any damage. So let's take a look at it. We can mouse over message here, and you'll see message is set to hello world now. So this is what we do when we debug. We can go through the code and see what the variables actually are to see why our errors or why our bugs are there and such. And you can also mouse over message up here and see it's set to hello world. Okay, so basically we can do some more things. Let's try to press stop here, and on the line below we write message equals just hello, and then we try to set this breakpoint on debug.log, and we copy debug.log, and let's put it down here again. So now we have these 3 lines of code, and now we can start stepping through the code to see how the debugging actually works. So save this, attach it to Unity again, go back into Unity, and stop the game and play it again. Okay, so now we have a breakpoint, and we can see message is equal to hello world. And there are some different options up here. There's one called StepOut, one called StepOver, and one called StepInto. So right now we will look at the option called StepOver, and I'm going to use F10 to step over, and StepOver will step from one line of code to the other. So let's try. If I press F10, it jumps to this line of code here. It is on this line of code, which means it haven't executed this line of code, which means that message is still hello world. If I press the F10 again, you'll see that message has now changed to hello, because this is exactly what this line of code did. So if I mouse over here, message is always hello. And if I step again, well, then it just wrote debug.log, this message here. So that's how StepOver works. StepOver jumps to the next line of code every time you press F10. We can also take a look at the different breakpoints, because you can set more breakpoints in a code and jump from breakpoint to breakpoint by using the continue button. So if I would continue, let's see, and stop and play here, and we break the code. And if I set another breakpoint down here, then you'll see instead of pressing F10 to jump each line, I can simply press continue, and then it goes to the next breakpoint I have. So now message is already set to hello here, as you can see here. Another thing we can do is to add something called a watch. So if we have a big a big function with lots of different variables in it, and we would like to keep track of a specific variable, we can add a watch. So we can right click on message, we can go to add watch here, and then you'll see it opens up this window here called watch, and it actually watches this variable here. And we can add as many variables as we want to. If I press stop here and I add another private integer age, for example, and say that age is equal to 1, and down here I say age is equal to 10. Well, then I can right click on it and say, of course I need to run the game first, so I can save this, run the game again, and rerun it out here. You see it breaks. Then if I go to my watch 1 here, you'll see message is still there, and I can right click on age and say add watch. So now I have both a watch on both of the variables, so I can keep track of them. And we can see age is 1 now, and hello world is message is hello world. If I step once, step again, then you see message change to hello world. And if I step one more time from this line to this, you'll see age change to 10. So this is the very basics of how you can keep track of your variables, and what you can do to control or check if they're set up correctly. But maybe this doesn't make a lot of sense yet, but we will go into details with these things later and see how they make sense. So this is how StepOver works. So let's try to take a look at StepInto. Okay, to test StepInto, we will have to create another function. And first of all, I'm going to show you how it works when we are using StepOver, and then I'm going to show you how it works when we're using StepInto with the function. But underneath start, we can make a private void function called DoSomething. And the DoSomething is basically going to do all the operations for us. So all the code in here except the last debug.log, we can cut it and put it into DoSomething and delete that one debug.log. So we will have a DoSomething function with age equals 1, message equals hello, and age equals 10. Up here in start, we call DoSomething so that we execute it, and then we set a breakpoint on 13. Okay, so if we attach to Unity one more time, and we go to Unity and run the game, you see it should break. There we go. And now that we want to test it, or we would like to look at StepOver first. So now I'm at DoSomething, hello world, a message is equal to hello world, and age is 0. And if I press F10 once, it executes the DoSomething and changes message to hello and age to 10. Okay, so maybe I'm running my program and I don't understand why message is changed to hello when it was hello world just before. So I would like to take a closer look at the functionality inside DoSomething. Keep in mind that this is a very simple script and we have DoSomething right here, but maybe you have a lot of functions in different objects and stuff, and you would like to step through all the objects to see the different functions they call. So this is a very easy to understand test environment, but in reality you might have lots of different scripts you will have to step into, and you have to step into different functions to understand everything that's going on. So let's try to stop the game, and let's try to attach it one more time. And now we would like to use step into so that you can see the difference between step over and step into. So if we run the game again and we use step into, you'll see that step into is F11 here. That's step out, sorry. Step into is this one. It's F11 to step into something. And before we stepped over, so we just jumped to line 14. But now we try to press the F11 button. And as you can see here, if I press F11, it jumps into the DoSomething function. And it says H2 1, message to hello, and H2 10 instead. And if we keep pressing this, it jumps back to start. So now we saw what happens into DoSomething. So that's exactly how step into works. So if we want to test step out, we can actually attach one more time and go to Unity and restart our project. So step into jumps into functions, and step out basically jumps out of functions. So if I press F11, jump into DoSomething, and what is it? It's Shift F11. So I'm just going to click up here to step out, because before when you stepped into it, jumped to this line, and then it went out. But now we're inside the function and we saw what we needed to see, so we can just step out already. So we click here and it jumps out of the function right away, and it already executed everything in there without stepping over everything. So these are the basic functions for debugging in Visual Studio, or debugging in MonoDeveloper for that matter. Okay, so before we start debugging the actual project that I created, I would also like to show you how you can actually take a closer look at lists and arrays. Because if we have an array here, let's say we have an integer array called numbers, and this one we are just going to serialize so that we can see it from the inspector. And the same goes for list. I'm just going to show it with the array here. Well, then we can simply go to our game here and say we have numbers. We have 5 numbers here. We have 6, 5, 3, 5, 8, 1, 2 or something. So if we have an array or a list or something, and we need to check what's inside it from our code, and it isn't public like this, well, then we can also go into our code, set a breakpoint, attach to Unity, run the game. And again, we are able to inspect the structure here by holding the mouse on numbers and clicking the little arrow here, and you'll see slot 1 is index 0 is 3, 1 is 5, 2 is 8, and so on. So this is also very handy when you need to check what's inside a list or what's inside an array. You can also right click on it and add a watch, and then you can also check it here. And of course you can change something, and you'll see the changes down here. So if I would write some code that says slot 1 is equal to 8, then you will of course see that it changes down here as well. I can just do it very fast. If I say numbers 1 is equal to 8, if I could hit the keys, then you'll also see if we put the breakpoint, we relaunch our game. Oh, I forgot to attach. Always need to attach to Unity, else it's not gonna fire. There we go. We can see numbers. We have our watch here. 1 is 5. If I keep stepping over F10 and F10, then you'll see that slot 1 changed to 8 now. So this is also a way to inspect these things, and it works with all kinds of different structures here. Okay, so now we have a basic understanding of debugging, and we can start debugging those small scenes I made so that we can get a better hang of it. So the point of all this is that you should be able to find the errors in your games, or in my tutorials for that matter, when you run into something, by debugging through it and seeing what values are wrong. So that was the intro to my Visual Studio debugging course. If you haven't done it already, then please remember to like my Facebook page, follow me on Twitter, and subscribe to this channel. Also, remember that InScope Studios is a community founded page, which means that all your support is very important to me. You can support me by going to the Patreon page in the top of the screen, where you can get different perks if you support me, like private tutoring, or you can actually also get all the projects that I ever made, or and all future projects. Also, if you aren't interested in supporting me on Patreon, please consider to go to the link on the bottom of the screen to acquire any of my current projects. Thank you very much for watching.